Okay, it's recording. Yo, what's poppin', people? This is the final presentation for not this one. Presentation on CS 550. Simply type a lambda calculus by Z she and biology something Lakshman.
No.
Do it. Balaji Lakshman. Wait, we'll start with the catalog.
Recording?
Yeah, we're
You
recording.
just said like fuck and shit all that.
It's okay. It's for the views. It's for the entertainment purposes.
No, dude, it's good.
I'll delete that in the post. Catalog.
Just start
And
again.
the calculus. No, we'll delete that in the post. It's
Dude,
easier
you were
that way.
typing.
Yeah,
You were
That's-
typing in the middle.
it's a presentation. It's not. It's not. We're wasting time. Catalog. Lambda calculus. We're gonna talk about lambda calculus, mini language of CS 515, and this STLC interpreter, which, in case you don't know what is STLC, it stands for simply type lambda calculus. It still sounds dumb, but program evaluation, adding typing rules, and so the rules and the formulas. Lambda notation. This is the most important idea I want you to know. Lambda notation allows us to control higher order function, which input and outputs are the self of the function. That means the function are able to control itself as the output. And this is the basic term. So mn and n equals x, or mn lambda. Lambda. It's this lambda here is supposed to be the symbol, but I don't know how to type it. So I did it this way. Next slide. The type are static, and the stats are not. This is the difference. And then static. Functions application to argument is not allowed unless the domain is the same as the argument, such that the example here, like the function which takes in the value of function. Yeah, that is the special attributes of the lambda type, the calculus. And then here's the simple type. It takes the input A and B, and this is two types in a pair. And slide 8. The simple terms, the x here means super descriptive, and it's really similar to the slide 5, this one. All right, next slide. Here is the typing judgment. You have T, and the T, and you have x1, a1, x2, a2, x, n. It's really self-explanatory if you don't understand. Okay, I want to spend my time talking about the typing rules because they're important to understand. The first is tautology. This one. So x of a is going to equal x of a. Tautology, like 270 that we learned. And then the second one, m and n has a type that is m produce. And the third one, if x has type a in the scope of m, which as type b, we make m a function of x. And then function takes a to b. I want to repeat. If x has type a in the scope of m, oh yeah, you can see my mouse, right? Which has type b, we make m as the function of x, and the function makes a to b. Boom! Energy, right? And the fourth is if x has type, or if m has type a, and n has type b, then m and n has type A times B. This one is a little more complicated, but I hope you get the sense. If you don't understand, you can refer to the book page 261. And if not, I can't help it. The summary: program is made safer because errors can cut at compile time. This refers back to the slide. This one, the rules of the formula. Then the second summary: specificity is enhanced by using domain and the codomain. Because it allows domain and the codomain. Therefore, we can specify. And then the rules of type are based on the math. I'm sorry. Next, I want to talk about Boolean and the arithmetic expression. The arithmetic expression means there are a few arithmetic language. Truth, false, if, the successor, the predecessor, and the return value. Or if there's an error, you return an error. The typing rules. The truth, true and false, which is in the format of Boolean. And then 0, that's a natural number. A successor is also a natural number, and the predecessor is also a natural number in the Boolean arithmetic expression. Next, this is a little more complicated. The STLC and BNF, the simply typed lambda calculus. So T has value of truth, false, true, false, true, false, like the arithmetic language I talked about right here. Has true, false, and if true, then T2, else T3. And 0, the natural number. The successor, the predecessor, they're all natural number. And then whether it's 0. They're very self-explanatory. And I'm going to the next one. The lambda is or maybe nested. The equation is if x has a probability of t1, therefore t2 has probability of t2. And if lambda x has t1, t2, then t1 is going to be t2. I don't know if